All right, welcome to Wednesday. I didn't think we'd be holding this webinar before the Iowa caucus results came in, but here we are. In all seriousness, this week is National Green Week, which is an effort that encourages schools to engage in sustainability-focused lessons, projects, or activities between now and the end of April. It's only fitting then that we're going to delve into how you can design and build a zero-energy home that costs less to own from the minute you walk in the door. We're going to cover good design, material choices, construction methods, appliances, lighting and equipment, and most importantly, you'll learn how to approach construction costs and financing so that the economic benefits will begin on day one. Here to walk us through that process is Bruce Sullivan. He's a building energy efficiency consultant and trainer, and he's been helping people improve the energy efficiency and reduce the environmental impact of their homes for more than 30 years. He has provided training to builders, designers, code officials, and others around the Northwest. And he has built his own low-cost, zero-energy home, so he speaks from firsthand experience. Bruce is also the energy consultant and blogger for the Zero Energy Project. While it might be a new year, we've got an old friend helping us out with these webinars once again. Who, might you ask? Well, it's PowerShift by NV Energy. You can never save too much energy or money, and that's why NV Energy has created PowerShift to help its residential and business customers conserve even more energy and save money on their power bills. PowerShift by NV Energy is also about providing you with excellent customer service. It's your one-stop shop to find all the energy-efficient products and services to help you boost your bottom line, along with convenient ways to manage your account. PowerShift Energy Advisors are dedicated to working side by side with business customers to discuss their needs and to find energy efficiency solutions that save money. Plus, their Business Solutions Center is the place to go to discuss your bill payments and account-related questions. For more information, please visit nvenergy.com/PowerShift. Now, during the course of today's presentation, you could submit questions for our guest at any time. Simply use the questions box that's probably on the right side of your screen. Now, I'm going to review those questions and I'll pose them to Bruce at the end of his presentation. Bruce, if you're ready, we're all set to learn.
Great, welcome everybody, and thanks for having me here. I'm really excited about going through some of this information about zero energy homes. I think we're really on the cusp of a huge shift in the housing industry, one that I've been personally waiting for quite some time. So I'm really encouraged by the number of people that are here to join us today, and I'm looking forward to receiving your questions kind of at the end of the webinar. Let's just get started then. I have been working a lot in the last few years with the Zero Energy Project, and you can see their website, zeroenergyproject.org, online. We have a monthly blog with some great stuff, and so everything I'm going to say today has really been said already there on that website. I'm also working with EVA, and just last year developed a day-long workshop for zero energy. We call it the Path to Zero Energy Homes. It's kind of the EVA approach. So if you're planning to attend the conference in Denver in October, you can see kind of the 7-hour version of this particular program. So what I've had to do is really kind of condense this and squeeze it down. We can't get into a lot of detail about construction details or that kind of thing, and really kind of hitting the high points here. So let's get started. Today we're going to talk about how to bring zero energy homes into the mainstream by basically making them the same price as existing homes, and we have several different ideas on how to accomplish that. We're also going to talk about some of the elements of a zero energy home and how we can make the zero energy home essentially cost neutral with other homes in the market. First of all, we need to get kind of the definition out of the way. A zero energy home produces about the same amount of energy as it consumes in a year. This is a very simplistic kind of definition, and I like to keep it fairly broad. We don't get into source energy, site energy, and all that kind of stuff, but just, we're looking for a home that basically produces as much energy as it uses. That's a big deal. Buildings contribute about 40% of the global warming that's occurring right now, and as we've been hearing lately, we only have a few more years in order to get this under control. We're already kind of behind the curve, and unless we take very significant action within the next 10 years, we will see some of the worst effects of climate change. So we need to take some action, and we can, I think, still do that if we act aggressively. One thing I like to think of is that, you know, whenever you build a home, or a commercial building for that matter, you are basically encumbering society for 100 or more years. That home is going to be around, it's going to be using energy for a long time, and so what you do today has long-term impacts. So what you're really doing when you pay a local designer or builder to do a clean energy home is that you are essentially helping us with our future energy needs. We'll talk a little bit about climate, but I just wanted to point out that, you know, what zero energy kind of depends on where you are. And a zero energy home in Florida is going to be much different than one in Minnesota. And for that reason, you know, we can't have any kind of blanket, we can't really have a blanket set of design considerations or construction practices that are going to apply to everyone everywhere. This is something that you have to develop kind of on your own for your local climate and for your local economic situation. So I think that what we're going to do today really is give you a menu from which you can choose the different elements, and that will fit not only your practices but your local market and your local supply, supply chain and that kind of thing. So it's really a menu that you can choose from. It's not a prescriptive path, say this is the way you have to do zero energy. So if the average house in the United States uses about 29,000 kilowatt hours of electricity a year, or the energy equivalent of that, if you were try to put that much photovoltaic panels on the roof, obviously there would not be enough room. And so the conservation is really a key element of building zero energy homes. We have to get the energy use of the building as low as it can possibly be. And what's really cool about the development of the industry in the last, 5 or 10 years is I think that we've made amazing strides toward that goal of getting the energy consumption down to a very low level, something that almost any house can fit enough solar panels on the roof to supply that much energy. So I like to look at it the way Ben Franklin did, is we are not really talking about energy savings. What I like to characterize our move towards zero energy as being earnings. We are making money by using capital. So if you had $5,000 and put it in a savings account, you would get a certain return on that investment. And so that's exactly what we're doing with zero energy improvements to buildings. We are creating earnings, a string of earnings that eventually will cover the entire capital cost. What's really interesting about the whole idea of zero energy is that the return on your investment from putting conservation and solar on a residential building right now probably exceeds what you would be able to get from the stock market. So especially if you're dealing with people that want a fixed income, kind of their retirement communities, this is a much, much safer investment to make than putting money in the stock market. A couple of years ago, Rocky Mountain Institute looked at the initial cost of doing zero energy, or zero energy ready, ZER, and they found that, I'll just focus on the complete zero energy, about 5 to 10% extra cost. And they looked at several different building markets around the country, and of course there's quite a bit of variation, but what we learned was that it is a very affordable move to get to zero energy. Now, you probably, if you are familiar with the study, you might note that there were, some assumptions made about what it takes to get to zero, and I think that, you might quibble with some of those assumptions, but I think the overall impact of this was that zero energy is affordable in every market around the country, and in some markets it is an absolute slam dunk. I like to think of it in a little different way too, in that if you have normal monthly housing costs, principal, interest, taxes, and insurance. If you had a typical home, you might be spending a couple $1,000s a month on all those things. Well, we have one more monthly cost that is routinely ignored by the financial industry, and that's energy, of course. And so if we add energy into that chart, those are the actual monthly expenses that people are expected to pay. And really, what we need to do is to move on to the next, is to assume that we can take those energy costs and use them to invest in a better building. So without changing the overall monthly expenditure that we have for living in a home, we can have a home that's zero energy. And this kind of idea isn't anything new. In fact, you probably aren't going to learn much new in this whole hour, but I hope that we are able to put it in a context that says, yes, we do have the capability today of making every home a zero energy home. And this is kind of where we start, because it costs no more to live in a zero energy home than it costs to live in a conventional home. In fact, it probably is going to cost less once you factor in the price escalation of energy over time. You're going to be much better off by investing that utility money in the building rather than a monthly payment. Going back to the Rocky Mountain Institute study, there was they looked at some of the cost of ownership around the country, and this is not the full. They did more cities than this showing on the slide, but this is kind of a good selection or a random selection of what they did. And you can see that the investment to go to zero energy, and this is not zero energy ready, this is the full zero energy with the solar panels on it and everything, and that ranges anywhere from $15,000 to $20,000, and that in every case the savings exceeded the mortgage payment. Now, I think this is the magic of a 30-year mortgage, is that if you can take that initial cost and stretch it out long enough, then those monthly payments are going to be less than the savings that you get. So in a sense, if you finance this over 30 years, it is profitable from the moment you walk in the door. And I think that's what we call kind of the buying power of efficiency. So if you think of your energy savings as really being earnings, and you simply apply those earnings to a higher mortgage amount, you could make more. You could basically pay for any improvements in the building from the moment you walk in the door. In fact, you could be cash flow positive from the moment you walk in the door. Now, I think that one thing I'd like to point out is that we're not talking about taking your we don't have to be talking about taking your standard home and simply adding $20,000 to $30,000 in cost. I think a rational approach would be to kind of adjust the cost overall, but know that if you spent $20,000 to $30,000 on energy efficiency improvements and solar panels, that you could recoup that money from the minute you walk through the door. Oops, sorry about that. Here we go. We're back on track now. Sorry. A slip of the mouse. There are people around the country that are doing this. I'm going to highlight a few of the builders that are currently in the Zero Energy Ready Home program from U.S. Department of Energy. And this is Thrive Home Builders in Colorado. Of course, has gotten a lot of notoriety for the kind of buildings that they're doing. This is a home with an average monthly bill of or average monthly savings of $3. They save about $4,000 a year, and that's money that they can use to make an extra mortgage payment. So in this case, that's $325 in extra mortgage payment, which would more than finance the energy improvements. Emory Group in Georgia is doing something similar. The savings in this case are $158. How much more house can you buy for $158? That's about $31,000 in additional mortgage payment that you can afford and still not exceed the same monthly budget. So I think that's kind of what's really key here. In Arizona, Mandalay Homes is doing something similar. They've got really great subdivisions, and they take a slightly different approach. Their homes aren't entirely zero energy, but they're kind of grid aware. And so these homes generate most of the energy that they use, and then use a very attractive billing rate from Arizona Public Service in order to keep their energy costs extremely low. But it's also a very small, you can see that the solar panels there are not as big as you would normally expect to cover the energy use of an entire home. So they have smaller solar arrays, and yet they basically move all of their energy use or energy draw from the grid to the off-peak hours. And by doing this off-peak only, they can get a really attractive rate. I think they're paying something, the people in these homes are paying about 4 cents a kilowatt hour from Arizona Public Service. And the key element that we're going to see in a lot of these homes going forward is something that Mandalay has been using. They're using a solar storage battery to kind of keep those homes from drawing power during peak times. And so that battery is shifting whatever energy use they have off peak, and that's good for the customers that are getting really inexpensive energy. They're also good for the electric utility. Here's a really small house in the Pacific Northwest. Again, smaller houses mean smaller savings, but they also mean smaller costs. And so I think that's where we kind of factor this in. So let's look a little bit at the return on investment that we get from these homes. I'm not going to read all this chart, but you can look at it now or offline later if you want to download the presentation. I just like to point out that if you look at the return on investment for energy efficiency, it's not bad. You know, it may not be quite like a stock market, but it's a whole lot better than keeping your money in a certificate of deposit. And I think we need to start thinking of this as a positive investment instead of as a cost. And so I really won't ever utter the P word, that's payback, because I don't think there is a payback. Payback is kind of an irrelevant concept in the economics of these energy efficient homes, because this is really an investment that has a fairly attractive return. Here's another way that we can think about paying for zero, simply by making the houses smaller. This is a little complicated, but I'll try to walk you through it. And if you're really interested in this, I have got a spreadsheet, an online spreadsheet that you can use to plug in your own numbers so that you can calculate this for yourself. But let's say that we're going to look at the size of the home, the conventional cost, and the total cost for a zero energy home, assuming that the upgrade is costed around $40 a square foot. Now, you know, if your conventional home starts off at say 200 and you add 40, that's $240 a square foot. I don't know that that reflects the market in every local in every local market, or the price in every local market, but it certainly is somewhere in there, and you can do this kind of a calculation, you know, for yourself. So let's look at what happens next. 2,800 square feet. The conventional cost would be about $560,000. Well, that's, you know, in a lot of markets that's about normal. In some markets it's a little high. But what if you had that $560,000 and you just spent it on a smaller home? Well, if you go up to the cost for a zero energy house, you could build that zero energy house for less than 560,000, but it would only be 220 square feet. So what you've done is essentially reduce the size of the home in order to capture savings that you can apply to making the home better. Now, this is a value judgment, and I don't mean to offend production builders, but you know, a lot of times there are homes that aren't exactly efficient floor plans, and that you can live just as well in a 2,200 square foot home that is well designed as you can live in a 2,800 square foot home that is got a lot of wasted space in the floor plan. So let's think about this, you know, in a different, you know, go down a little bit now. If we started off with a 2,000 square foot house, and that running around $400,000 total. Now let's take it close to that, 408,000. That would be a 1,700 square foot home. So you can see that this gets a little more difficult as you get into smaller homes, but we can still make homes a bit smaller, capture the savings, even though the cost per square foot is higher. That's not the metric that we need to be looking at. We need to look at the total cost of the home versus the amount of energy that's being consumed and paid for. These homes can pay for themselves. The construction costs can be paid for simply by making the home smaller if we get away from this idea of judging homes as a cost per square foot. That's where real estate comes in. You really need to find a broker that understands these concepts of value so that you can convince the buyers that this is the way to go. If somebody's just selling cost per square foot, then they've really missed an opportunity to sell livability and future proofing of that home. So find a broker that understands these concepts, and that's usually one that's gone through a certification program. EcoBroker has one. The National Association of Realtors has a green designation. If you're in the Pacific Northwest, then the Earth Advantage has a broker training program. And focus on the cost of ownership and the benefits that people are going to get with these homes. I think one essential part of that is to have some kind of an energy rating or an energy performance program like Zero Energy Ready Homes, a really low HERS score or something like that. So there's also a lot of things that we need to do in the real estate market in order to sell these benefits. They've been largely overlooked, and there's a lot of work that we need to do there. There's also an awful lot of work we need to do to get these homes, the value of these homes recognized. Now, there's been some research over the years that show that certified energy efficient homes have a higher sales price. And so that's, good news, but it doesn't seem to be getting the kind of traction in the marketplace that we'd like to see. The most recent thing, Freddie Mac released a study just a few months ago last year where they showed that energy rated homes or Energy Star certified homes were about 3% higher value than non-rated homes. So I think this is the kind of thing that we really need to push in the market to get the real estate salespeople and the mortgage lenders to value this. That brings us to asset value. This may be the biggest stumbling block that we have to overcome, where we need to have appraisers that understand energy efficiency and can use the tools that we already have available. So the Appraisal Institute has an energy addendum, and that needs to be something that more appraisers should be using. And we also see the fact that in many of the multiple listing services around the country, they're starting to include energy performance information or energy certifications in the MLS listings, and that's a really valuable way to start establishing the value of these homes in the marketplace. We have a lot of work to do there, however. There are also lending products specifically targeted for higher efficiency homes. These are lending products that can stretch mortgage to income ratios or debt to income ratios, and also maybe go for slightly higher mortgage amounts. The main ones I think are from Fannie Mae. There's something called a home style energy loan, and in Freddie Mac world, it's the Green Choice Mortgage. So check with your mortgage lender and get them to participate in some of these standard mortgage products that will allow the greater value of the energy efficient homes to be recognized. And you can take this all the way to a zero energy home when you can demonstrate that the amount of money that that occupants are not spending on energy can be applied to the mortgage. We also see in some places around the country, we're financing through local PACE programs. These are called property assessed clean energy loans. A lot of these programs are targeted for commercial buildings, but there are a few that are also available for residential buildings. And this is something that has just been unleashed after spending several years in limbo. So I hope to see a lot more development around the country of these PACE loans as we go forward. Finally, everybody always wants to know about incentives. Yes, there are incentives for energy efficient homes, for solar panels, for insulation, for high efficiency equipment. And you can learn about all of that at the desireusa.org website, where you can find out what will apply in your specific area. So we won't deal with that too much. I also really encourage people to look at the local certification programs that can help you, all the way from a local green program to Passive House, or to the International Living Futures program. The program that most of you are probably familiar with already is the Zero Energy Ready Home from U.S. Department of Energy. Take advantage of these programs because they can help cover a lot of the basics and give you a good head start toward high performance. So I strongly encourage you to get involved in one of those. So let's look at what does it take to get to zero energy. What are our choices? And I like to think of this as a pyramid. It really begins with good design. You make a lot of choices at the design stage that are essential for getting good performance, and I need to stress that it's affordability begins with design, and we're going to talk a little bit about each of these steps along the way. Then obviously the shell is next. You want to have a very highly efficient shell, well insulated, low air leakage. You want to pick high efficiency equipment. Plug loads have become more significant now that we've reduced a lot of the other loads in the building. Plug loads, things that like televisions, etc., can become a pretty big factor. And then finally, you cap this off with renewables. And if you've done a really good job on the steps below, then that last step of renewable energy, which tends to be the most expensive one, can be as small and affordable as possible. So I think of this as, this is kind of the organizing metaphor for what we're going to talk about today, but also for your design and building process to use these steps going forward. Now, it is true, and I like to acknowledge this, that there are builders that have taken advantage of the fact that the renewable energy systems, specifically solar electric panels, photovoltaic panels, have become so cheap that some people are turning this pyramid on its head, and they are saying how much renewable energy will fit on the roof, and can we just design the house to meet that amount of energy use? Can we design a house under that energy umbrella? And that's perfectly legitimate design approach. I don't object to it, but I will point out that it's probably not the most affordable approach. And today we are going to focus on affordability and making homes that are just the same cost to live in as a conventional home, but but generate as much energy as they use. So we're going to move forward with that principle and consider renewables to be the icing on the cake or the top step rather than the fundamental one. So you really need to start off by modeling the building using an energy model like REMRate or BOPT or one of the other, at least a dozen energy modeling programs out there. Find one that you like and use it in order to help optimize the energy package. Now, we're not talking about just meeting a certification requirement. If your green building program says that you need to be 10% better than code, you don't stop there. Use the energy modeling software to actually judge what's the most cost-effective way to get the most performance, the best performance. And I think we should set zero energy as the target. What is it going to take to get to zero? And how do I optimize each of the steps? Is more wall insulation better? Is higher performance heating and cooling equipment better? And a lot of that is going to depend on your climate. So if you're building a home in Florida, you're going to have a different package than the same size home in Minnesota. So that's where it really kind of comes down to doing this local energy modeling with your climate in mind. In general, if you have a more complicated design, you'll have a higher energy use. It doesn't mean you have to build a cube, but it does mean to keep this building fairly small and consistent without a lot of jigs and jogs. That's easier to build, less expensive to build too. If you look at the total energy use, this is a study we did about 10 years ago. The numbers are a little bit off because codes have improved, but I think it's important to notice that your extra small, that your kind of Energy Star level home is going to use more energy than a small home if the Energy Star home is 2,800 square feet. So it's not just about getting certified, it's about getting certified and making that home as small as is necessary to meet the needs of the people that will be living in it. So small homes are going to be better. Don't forget where your thermal boundary is. This is one of the things that we've been working on for quite some time now, because people have this strange habit of putting their heating and cooling system outside of the building. So, you know, in most cases that's in a garage or a basement that's really outside the thermal boundary. So if you make a point of really understanding where that thermal boundary is and try to keep your heating and cooling system inside the thermal boundary, that'll make a big difference in the overall performance. Use sun tempering whenever possible. Doesn't have to be a full-fledged passive solar thermal mass, you know, kind of design, but windows to the south, living spaces on the south wall so that they get natural light and natural heat, and you can really perform almost as good. This is like free energy, so don't leave it behind. It's really amazing how some you know, one subcontractor can kind of jeopardize or sabotage the entire project. So communication is really, really key when you're collaborating with subcontractors and suppliers. And I am a really big fan of a checklist or some very clear written communication between designers, general contractors, and subcontractors, so that everybody is on the same page and dealing with the same set of expectations. So something in writing is really important, and this checklist is an idea. I mean, a good example might be that, you know, nobody's really going to be able to tell what, if you have an efficient water heater, or what the efficiency of a water heater is, unless they look the model number up on a list. So it'd be easy to get a water heater that's not the one that you are expecting to get unless you have that expectation written down. Also, it kind of goes into the same pattern with the general construction approach. I love the high efficiency benefits you get with some of the building systems, like insulating concrete forms and SIPS panels, structural insulated panels. But I think that it's also one of those things that's created a little bit of a barrier. We don't need to do some of those high-tech construction systems when stick framing will work. There's nothing wrong with the SIPS panels or ICFs, but I think if we're trying to make this mainstream, we need to use the systems that are already in the mainstream. And so that's what we're trying to do here, is say, how can I accomplish a zero energy house with a wood frame construction that most people are familiar with? So that brings us to the first step, really, after design, is to make it a very efficient shell. You really have two choices for this, and that's to make the insulated cavity thicker. That can be anywhere from 6 inches to 12 inches thick, depending on your design goals, or to use insulated sheathing on the outside of the building. So it doesn't really, I mean, I think everybody's got their favorite. My concern is that, you know, you have to make sure that that wall is tight, and in some climates, the thicker walls may not be as moisture tolerant as in other climates. The climate I happen to live in, my house has a 10-inch thick wall. I've measured the moisture in the cavity over the years and found it to be, you know, perfectly within parameters, less than 10% moisture content in the wood. So I don't think in my particular climate, which happens to be quite dry, there's a problem with double frame walls. In other climates, I think insulating sheathing is probably going to be required, especially if there is an issue with or a danger of moisture condensation in the wall cavity. These are the kinds of things that you can get into in some detail, but we'll just say that you need to find a path that makes sense for you in your climate, and make it probably somewhere around R30 to R40 to meet most of the zero energy goals in most of the climates. I'm a big fan of blow-in insulation in wall cavities, dense pack insulation, because you know, bats really don't fill the cavities and seal up quite as well. That's less of an issue if you're using insulating sheathing, but I think that's a good combination in most cases. Air sealing is essential. We're seeing a lot of homes that are using this advanced air sealing methods. Some of it's just, copious amounts of tape and caulk and duct mastic, and in other cases you have systems like aero barrier here that's starting to automate the air sealing process a little bit more. I think you can get good results with both approaches, and it really just matters how it fits in with your construction practices and your scheduling. A lot of people are interested in using spray foam. It's got a lot of advantages. It's got a high R value. It seals up the home really well. If it's high density spray foam, it'll add some shear value to the structure. But it's also got a fairly high global warming potential. And so here's an old chart that came out of Building Green a long time ago, to showing some of the global warming potential of the propellants that are used in standard spray foam. You can avoid the global warming potential of those blowing agents if you use water-blown foam, or if you use one of the new hydrofluoroolefin blowing agents that are available from Honeywell and Chemours. So talk to if you're interested in spray foam, if you're committed to that, try to find a product that doesn't have the global warming potential, because that's kind of what we're trying to avoid. Don't forget windows. Windows are important for light and views and everything else. If affordability is important to you, then I don't think that you have to feel like you need to get some super duper European window with a U value of 0.1. Standard double glazed window can be purchased very affordably with a U value of about 0.25, and you just have to work around that. There are a couple of ways that you can work around the lower efficiency of the window by placing the windows more on the south side of the building. They get more sunlight that way. They're still net energy gainers. And maybe using window coverings and that kind of thing. So don't feel like if you're going to go to zero, you have to get some super duper European window in order to make that happen. Obviously, and don't let me forget to mention that there are North American windows that get down to 0.1 U value as well. But they're still quite expensive. And so I think that if affordability is an obstacle, that you can get the very best double glazed window that you can afford. And that's going to be somewhere around U value of 0.25, maybe 0.22 or 0.23, and then use other methods to reduce the energy loss in the building. So you can reduce the glazing area. You can make sure that those windows are really effective in terms of sharing light. Now there are some products coming out that deserve to be mentioned. There's a new R10 window that is on the market. It's actually using 2 panes of glass. It's a sealed double pane unit, so they're getting an R10 without using triple glazing, and that makes the window not only more affordable, but it also makes it a lot lighter and easier to handle. Efficient space heating is kind of the key to here. In a lot of cases, you can find really super efficient mini split heat pumps that are, have an HSPF of over 10, maybe 12 or 13. If you decide that, I think it's important to make sure that these are properly designed, because I'm afraid that a lot of heating contractors aren't understanding these systems as well as they need to. One way to kind of make it a little bit easier on everybody until we get better design is to use more than one single head unit rather than trying to take a mini split with 3 or 4 heads and make it kind of work the same way an old-fashioned central heating system would. So if you are building a super efficient shell with very low air leakage, these heating systems can be quite small, and maybe 1 or 2 smaller mini splits will be able to satisfy the heating and cooling need, and you won't need to put heating delivery in every single room. And I think that's where we're getting tripped up, is that people feel like they need to have a mini split head in every room, when that's really not the case. There are other ways to get around that, and we talk about that a little bit more in the EBA class that I'll be teaching in Duluth later this month, and also at the EBA conference in Denver in September. So we'll get in a little bit more into system design and how to optimize for these mini splits. People are still using ducted systems in zero energy homes, and that's fine, but we really need to try to bring those ducts into the conditioned space and the heating device itself. So don't forget to make space and in the design for the ductwork if you're using a ducted system. This can reduce the size of the heating system by 15 or 20% just by itself if you can get the furnace and all the ductwork inside the space. And it has to be designed from the very beginning. It's not something that you can do later. So involve your designer in how to place the heating plant and also the ductwork that serves the house. Ventilation in these tight homes is extremely important. Traditionally, that would have been a heat recovery ventilator or an energy recovery ventilator. I think there are some options these days for tight houses. The ductless systems, the through-the-wall heat recovery vents are something to look into and see if they work for your system. And I'm also thinking that especially when affordability is paramount, that maybe we need to dispense with the heat recovery and just have a really effective ventilation system that protects the occupants in the buildings, but we aren't trying to capture that efficiency. Now, if you do that, that's going to trade off with other efficiency measures, and you'll probably have to compensate for the heat loss in that ventilation air. But I think that something to keep in mind, especially if you live in a milder climate where heat recovery is not such a big deal. So keep an open mind about ventilation. Don't think you have to put an HRV in every house unless you live in one of those really cold climates. Water heating, heat pump water heaters are really the way that these homes are going, especially if you're going into zero energy. Heat pump water heaters have a lot of, I think, merit. You want to remember, though, that they kind of cool the space they're sitting in. And so if they're in a buffered space like a garage or a basement that isn't directly heated by the heating system, they're going to be essentially capturing some waste heat, but they're also going to make that space fairly cool. And so you want to anticipate that. If you're accustomed to putting your water heaters inside the conditioned envelope, then you can attach a duct kit to these heat pump water heaters so that they will exhaust the cold air outside and not cool off the inside of the house. We're still learning quite a bit about how to use these most effectively, but they've been around now in this latest generation for, I don't know, 5 or 6 years, and they've been performing very effectively as far as I know. And I've had one myself for 5 years and had never had a hiccup. Something on the horizon that's really very interesting is a split system water heater, and you'll probably recognize this if you've been going to conferences and things like that. This is it uses CO2 as a refrigerant, and it's a split system so that the energy being captured is actually outside of the building, and then there are pipes that take that hot water into the tank. And this is a really effective way for, especially in warmer climates, to capture energy from outside and not have that energy penalty of a heat pump water heater inside the conditioned envelope. It's actually been used in colder climates too. I saw one in Montana a couple of years ago that was doing just fine. So they're quite expensive, but they are show a great deal of promise. Some people have wanted to just use an electric water heater and add extra solar panels. That's depending on your climate, that's possible. I would do a real careful energy model of the building in order to see what the cost is. I'm pretty sure that you're going to find that it's more expensive to add the solar panels to power an electric resistance water heater than it would to be using a heat pump water heater. Lots of lights and appliances. Won't get into that too much, but I just really encourage people to use the Energy Star products list, and don't just pick anything off the list. They highlight the top 10% in terms of efficiency of all the different categories of appliances. So start to look within that top 10 a little bit more to get the best performance. So we're going to talk about, and also I think the big one of the last beachheads of combustion inside these buildings has been the range. Induction cooking is something that is slowly catching on. I want to plug it because there's not a flame involved, and it's also quite efficient. Using natural gas or methane in houses, I think, is probably a thing of the past. I hope that doesn't offend anybody, but it's a powerful short-term, is much better than some of the other fossil fuels. There's so much leakage of methane from the piping system that it's actually almost as bad as coal. And so we don't really want to see that kind of thing. But we can use, I mean, if we have heat pumps for water heating and space heating, we've got induction for the range. I don't think there's really any reason to be using a fossil fuel anymore. This is just a really kind of interesting analysis that I did recently for the Zero Energy Project website, where when you think about using gas directly and using induction with grid power, you're producing a lot less CO2. This is a little counterintuitive, but I think the efficiency of the induction plus the amount of leakage of methane from the gas distribution system really kind of makes that a problem. And of course, if you're using on-site solar for the electricity that powers your induction range, it is definitely carbon neutral. So here's, if you go through the whole process of looking at what are we doing with the energy efficient homes these days, I think zero is the next step. And we need to start investing in the bones. Now, this is something that is difficult for the housing industry to really give up the pretty interiors, the nice finishes, all that stuff, but we don't want to cover up the essential functional parts of the building anymore. We have to start investing in the bones that are going to stay with that building for its entire life. The cabinets and the finishes will all be replaced multiple times during the life of that building if you build a sturdy house. And so we need to put the money that we need to invest in this into the bones and let the interiors and the finishes kind of come over time. I understand that if you're selling homes, that those finishes are what appeal to the buyers. Let's work on the value of what's behind the walls. So right now we've taken our building from design to the point where it's ready for solar. We've reduced the energy consumption in all those different components quite a lot. It's now, with a great envelope, with great equipment, we've oriented the building correctly, and those historically have been the most affordable measures to take. Now we can start thinking about the renewable options. And for most people, this is going to mean on-site renewable generation. If your home does not have access to sun on the rooftop, then we see a lot of community solar and other kind of systems that can allow people to essentially buy into a renewable energy for themselves, but also as a way to encourage the broader use of renewables. I want to take just a moment to mention that the way I've put these ideas together for my own house. My wife and I moved into this house in 2015, so we've been in there almost 5 years now. It's pretty small, 900 square feet, cost about $180,000 to build. The ceiling is R60, the walls are R40, that's a 10-inch double stud framed wall. Standard 12-inch I-joists in the floor, and then all of the insulation is dense pack fiberglass. So we're getting some pretty good energy values there. The windows are nothing spectacular, 0.22, but they're the best double glazed window that I could buy at the time. I spent a lot of time working on air leakage and got it down to 1 air change per hour, just with lots of caulk and tape and foam and everything. There's one small ductless mini split heat pump and that has an HSPF of 13.5, so it's a really super high efficient unit, and it's also one that is very effective down to minus 14 degrees. So in my climate, that was an important thing. I do have two small electric space heaters mounted in the walls, and they've never been used except maybe to take the chill off the bathroom once in a while. So they've never actually been needed to heat the house. The water heater is a heat pump water heater with an energy factor of 2.5, and all that system, all those systems run with a solar array of 4.3 kilowatts. This is actually less than the energy model predicted I would need, so I was a little nervous, but you know, just because of the way the house is sets and the fact that the energy model is probably a little conservative, we were able to make this house zero energy over time. In fact, we had enough left over that we could buy a used electric car, and we don't drive the car, you know, more than 4,000 or 5,000 miles a year, but all of the electricity so far for the car has also come from that small solar array. Some people are still thinking about living off-grid, and I think the modern world is such that we want to be connected to the grid. We want to share our excess and be able to draw from the grid when necessary. So I think being on the grid is actually good. The net metering policies around the country are rapidly evolving and changing, and you get a much better deal from your electricity, from your electric utility in some areas than in other areas. And so I think that you really just need to be sure you understand the net metering policies of your electric utility before you engage in the project, to make sure you understand what you're going to be getting out of it. So you know, this idea of the duck curve or the peak power is causing a lot of us to think about how do we shift our energy use off peak, and one of the ways to do that is for the utility to have grid storage of electricity. And we've seen this now most famously, I think, in Australia, where Tesla basically provided half a gigawatt of energy storage, and they can do it quite quickly too. I think it only took them a few months, about 6 months, to install all their systems. But Tesla is certainly not the only one that's providing that. Sonnen has a battery system, LG has a battery system. So there are quite a few others out there, and you should kind of check those out. This energy storage for individual homes is allowing companies like Mandalay in Arizona to offer these kind of grid-aware homes that are never using power during peak times, and this is getting them an extremely attractive electric rate for the power that they do buy off-grid at 4 cents a kilowatt hour. So something to think about, you know, putting together a package that kind of makes sense. Don't forget that energy used for for heating and cooling and lights and appliances is not the only thing that we're having to struggle with now. We really need to think about transportation and land use, and so locating your zero energy house in some far-flung sprawl of subdivisions may not be the best choice. If you can build more compact urban areas, I think that can make some sense. So, you know, consider that anyway. Don't disregard transportation and land use in your decision to develop new homes or to purchase a home. So homeowners are the ones that really benefit from this. And it's not just about saving money, although that's certainly part of it. It's about fantastic comfort. It's about healthy indoor air. It's about quiet homes. So these are the benefits that you can sell to people who are interested in that. Everybody wins with these ideas of really good efficiency. I think that what we need to do now is to be able to convince the homeowners that this is a good idea, and that's going to take everyone in the construction industry working together to build these communities and to make sure that we communicate the values and the benefits to other people. I work with this organization called Zero Energy Project, where we list builders and designers and provide real estate support for, you know, information for real estate brokers and that kind of thing. And I think I encourage you to go and check it out, and maybe you'll find some information that you're looking for. I want to just end with a quote from my hero, Bucky Fuller, who basically said, if you're going to change the world, you can do that, and we have to start doing it with design. So I want to thank you guys for joining us today. I hope I've given you something new to think about, and I look forward to your questions.
All right, thank you, Bruce. And I'm glad you're looking forward to the questions because there are a lot of them. So we're going to dig right into them. A pretty easy one to start with, and it's really more of a clarification. Fernando wanted to know, what does ZER stand for? Is that Zero Energy Ready?
Yes, it is. Zero Energy Ready.
Okay.
Sorry, I didn't define that.
No, it's okay. I thought that's what it was, and I sent that to him, but I just wanted to get clarification on the record for that, so thank you for that. Okay, wanted to jump into a question from Glenn. So we're going to go back to a little bit earlier in your presentation. You were showing the spreadsheet about Zero Energy to be $40 a square foot, which is about 20% of the $200 per square foot construction cost. However, you were also saying that Zero Energy adds about 5 to 7%. So why the differential, he wants to know.
I think that's just my mistake. You know, when I put that chart together quite a while ago, I kind of pulled a number out of the air. So I wasn't trying to make those numbers indicative of reality, but to show how you can adjust size in order to compensate for the extra cost. So you could easily redo that chart and you put $20 a square foot in there instead of 40, and then, you know, make the lines go where they will. In fact, that calculations for that chart are available in an online spreadsheet, and if people send me their email address, I will send them a link where they can plug in their own numbers for the costs of the house and the costs of the Zero Energy features, and come up with a size compensation approach. So if you decide that you want, if you're currently building a house that's 2,400 square feet, how small do I have to make it to pay for all of the costs simply by making the house smaller?
And Bruce's email address is right there on the screen, so make sure to send him an email and he will get back to you. Wanted to get to a question from someone also named Bruce. He said that he's read about how insulated glass sometimes leaks the gases that are between the glass, then that was going to lower the R value over time. Now he has a supplier that offers triple glazed glass for a small added cost. So can you kind of speak to the whole triple glazed, triple pane glass, or triple glazed glass with the gas inside and all that stuff? Can you kind of talk a little bit about some of the leakage maybe?
I'll try to. You know, the idea that the inert gas, it's usually either argon or krypton, somehow leaks out of the sealed glass unit has been around for, ever since I've been in this business. And I don't know that it's ever been substantiated. There is a little capillary tube inserted into that allows the pressure inside the sealed glass unit to equalize with the pressure outside, and that's for transporting the sealed glazing units over mountains and things like that. And as I understand it, the pressure equalizes within the capillary tube, and so you never really get any outside atmosphere inside the sealed glass unit, even if it's full of argon or krypton. And so it's one of those things where I've never heard of a substantiated study that said that the gases, the inert gases, will leak out of a unit unless it's actually broken. I mean, the seal can actually fail, but it doesn't leak out over time just through natural occurrence. And regarding triple glazing, I'd say, you know, you buy windows. If you're concerned about efficiency, you buy windows based on the U value. And if you can design a house around a window that's got a 0.22 U value, then you probably don't need to go to a 0.15 window. And so this is one of the trade-offs that I think is really, really important for getting affordable zero energy homes. And windows may be the poster child for optimization because they are probably the most expensive part of a house. And if you want to improve the efficiency significantly, you're going to have to go to a pretty low U value window, triple glazing. There's that skinny triple that is now available from one or two manufacturers. So I think we're improving window efficiency, but I would say it might be cheaper to optimize the overall performance of the building by going with the very best double glazed window you can find and increasing the air leakage, or sorry, increasing the air sealing and reducing the air leakage, increasing the insulation, buying a more efficient heat pump for space heating. So this is where energy modeling really becomes important, because you can start to create different scenarios, different packages of energy improvements that will get you to the same point, and then you can find the one that's the least expensive. Another thing about windows, I think, that has always been an issue in home design is that people love windows, and even though they're the most expensive component of the building, they want to put a lot of them in there. Well, they also are the component with the highest heat loss. So if you can manage to constrain the design to the point where you're only, well, my house has 16% window to floor area ratio. If you can keep that down to 20% window to floor area ratio, then you're probably going to be much better off than trying to compensate for the heat loss through a much bigger expanse of windows.
I know we're just past the top of the hour, but there are a whole lot of questions coming in, and we typically here on these webinars don't weed them out. We make sure we address all your questions. We're very glad that you've all attended. So we are going to get to your questions, and we're going to continue on with Dawn's question. She had a question about your heat loss and massing slide. What is the difference between one-story versus two-story?
The surface area to volume ratio of a single-story home is generally higher. Surface area to volume, right, would be higher for a single story. If you took the same floor area and stacked it on top of each other, you'd have something that approaches a cube. It's the early passive houses were almost always something that looks like a cube, because that was the way that they got their surface area to volume ratio down as low as possible. I suppose if you could build a sphere, that would be the best surface area to volume ratio. But today, I think that we can be a little more flexible. You don't need to build a cube or a sphere. You can do a ranch style or whatever. My suggestion in terms of overall building massing would be just to try to keep the number of corners fairly low. If you've got a minimum of 4 corners in a building, try not to go over 6. If you get into some of these really crazy designs with dormers poking out everywhere, and you not only make it more you change the surface area to volume ratio, but you also make it much more difficult to get a good insulation job, and you make it much more difficult to air seal those complex designs. So something that's pleasing, aesthetically pleasing, but not quite so zoomy, I guess you might call it, is a good way to make it easier on yourself when you design an energy efficient home of any kind.
Gotcha. We're going to go to a question from Jim. He said that using the same home electric heat will prevent a builder from federal tax credits. Now, I got to add a little bit of context here. So, because he and I had a great back and forth dialogue on this question. He's defining same home as the same blower door and installation, and the only difference is it's gas versus electric heat. He was finding the cost of the heat was over $250 higher per year versus gas. He said that he lost tax credits on 7 homes last year using air source electric heat pump HVAC. Conversely, he would have received federal tax credits if he had used a 90% gas furnace. And just for good measure, Bruce, he has also built a zero-ready home several years ago. So can you talk a little bit about the tax credit angle here?
I'm afraid I can't shed any light on that. I think if he had been using an electric resistance, I could have kind of seen how that would work. But if he's using an electric heat pump, then it seems like he should have been eligible for the tax credits. But I'm certainly not an expert on tax credits.
Okay. I want to move on to our next question. It comes from Margaret. She has started virtual reality design of a home last week. So this is going to be west of Denver. It's going to be about 9,200 feet elevation. It's going to be net zero electric, trying to go for LEED Platinum, and it's going to be built to the 2018 code, or at least that's what governs the area where she's at. Now, she was advised to add gas for emergency cold spells, but she wanted to get your opinion on just adding more batteries versus grid storage. This particular property, or structure, I should say, is estimated to be about 3,000 square feet, which includes a rentable apartment.
Well, that is an interesting problem. And I think it comes down to the energy model. I think the energy model would be really important to know, how much grid storage would you need? I mean, at that high elevation in Colorado, I'm not sure how many days of clouds you might have to accommodate. But in any case, more insulation and air sealing and really great windows would give that home a longer kind of thermal flywheel to be able to roll through any power outage. So if they're concerned about the power being off, was it an off-grid home?
Well, this is in design right now, and
Okay.
She did not say anything about being off-grid. She did mention that it was going to be net zero.
Okay, so but her concern is that if the power goes down, how long can her house stay warm? That's, I think, a case where you really need to make sure that you've designed the house with tons of insulation and air sealing. I think that's all I can offer. I don't have any other ideas.
Okay. Wanted to get to a question from Ken. He wanted to know, what type of alternative design do you recommend for the best energy efficiency? He lists, possibilities such as geodesic dome or straw bale homes, or underground home, or monolithic dome. Can you talk a little bit about some of the alternative building systems out there?
Well, I can. I'm certainly not an expert in that area, though, because my whole pitch here is that we want to make homes normal. Just the regular old stick framed house that's zero energy, because people have been working on domes and underground and things like that for quite some time, and I think they've gotten good success with it. My approach is always just to do an energy model and use the energy model to optimize the choices that you have to make. So if you're building an earthship, for example, you need to understand the heat loss to the soil around it and how much glazing you're going to put in. So energy modeling is actually, I think, very useful in terms of making some of these design decisions. And we see the energy modeling in programs like Energy Star and Zero Energy Ready Homes as really being a compliance tool, but it really should be a design tool to help you to choose the path that you want to take forward. And that's where it gets a little bit more difficult to do some of the alternative construction methods like earth sheltered with standard energy models, and sometimes you have to come up with your own kind of approach.
Okay. I had a question for you, actually, Bruce. It's on the topic of SRECs, so renewable energy credits.
Okay.
Because you were talking about the financing part of that, and that's always fascinated me about this, and I've been a long advocate for the whole cost of ownership and how, exactly what you were saying, I completely agree with it. You make some of these improvements, it reduces the energy bill more than it affects your mortgage. Part of that financial calculus is or can be these renewable energy credits. Now, I live in Illinois. They're available here. I take advantage of them. I have solar panels on our roof here. But I have a relative who lives over just across the border in Missouri that cannot take advantage of SRECs. Apparently, they're not eligible for them or whatever. Can you talk about why that is, or if people that are in those kind of situations have another path to capitalize on the renewable energy credits that they're producing?
In a word, no. I really can't speculate about that. I'm really not familiar too much with that, except that to say that every state has its own rules, and I suspect that this is some kind of that the rules for Missouri are different than they are for Illinois. So for example, where I live, I got a utility incentive for the efficiency of the building and for the solar panels. And I did not try to capture any other renewable energy credits because the incentive from the utility claims the credits at least for some time. So I think there are rules about you can't claim the credits twice. And so,
Right.
you see what I mean? I think that that's probably what's occurring here, but I couldn't be sure.
Gotcha. All right, we're going to keep moving on. We got another question from Bruce. He has read about PV panels that are also hot water collectors. Is that a possible hot water heating solution? The PV panels that heat the domestic hot water?
Sure. I mean, I've seen the product advertised where they have it's got the advantage that the water keeps the PV cells cooler, and so it improves the efficiency somewhat. I guess the question always comes down to economics. Would it be less expensive to buy that particular type of system and install it than it would be to have a photovoltaic array and a heat pump water heater? So I think that in terms of just fitting in with the construction practices and making this a mainstream thing, it's probably easier to have PV panels and a heat pump water heater than it is to have some exotic, solar panels that have water tubes running through them.
Gotcha. Question from Glenn. He says that part of the problem with valuation of solar energy is that solar cells often reduce the attractiveness of the home, especially when on the front roof. I don't necessarily concur fully with that, but he wants to know if you've seen or used the Tesla solar glass roofing system, and do you have any thoughts about its use?
I haven't seen it in real life, but you may not even recognize it if you're just driving down the street because it is so well camouflaged. And Tesla isn't the only one that sells solar shingles, by the way. There are several other companies that also do it. They just don't get quite as much press. And I think that that's got some advantages in terms of aesthetics. And if you're replacing your roof anyway, that it could be economically viable. I mean, I wouldn't rip off a perfectly good roof to put solar shingles on it, but if you're going to replace the roof or build it from, originally, then the solar shingles do make a lot of sense. And if they are efficient enough and they capture that, I think it does make some sense to do that. I don't have any experience, however, so I can't really give you a sense for how they work in the field.
Gotcha. Wanted to put out a final call for questions from the audience. Go ahead and use that questions box to send those in. We have a question from Elizabeth. She wanted to know or get your opinion on the point of sale programs where an energy audit or rating or the home energy score is required to be disclosed to potential buyers.
Oh, I love it. I think it's long overdue. I mean, right now what we have are people in the marketplace purchasing or encumbering their future without knowing one of the most important factors and one of the biggest expenses that they'll face in that future. So some kind of a home energy score or a rating at time of sale, to me, is essential for moving this forward. A lot of people end up buying homes that become burdens to them when they could have made a choice to buy something that was going to be more financially stable. So I'm a huge fan of time of sale ratings.
And I will echo that support for that too. What Portland, Oregon has done, and Colorado and some other places, big fan of that. Question from Robin, and it's based on the domestic hot water topic we were just talking about. She's well, actually, I don't know if it's she or he, but Robin asks, how does a true solar hot water collector on the roof system compare to a heat pump water heater system?
With the additional solar panels, solar electric panels that are required to run the heat pump water heater, I've kind of penciled it out a couple times, and at those times, the heat pump water heater with the extra solar electric panels was about half the cost of the solar thermal panels. So I kind of think that, at least at a residential scale, solar thermal water heating is probably not going to survive. In fact, it's already pretty much gone around my local market. And you know, it's more than just the economics up front. The fact that in the solar thermal panel, I've had 2 solar water heaters over my lifetime, and you know, I end up with way too much hot water in the summertime and not enough in the wintertime. So it doesn't really, the solar thermal water heaters don't match the usage as well, and you can't capture excess generation. If you capture more heat, you can't do anything with it. Whereas if you capture extra electricity that's not used in the water heater, you can use it for other things in your house or export it to the grid. So I think that, at least on the residential scale, solar thermal water heaters are probably on their way out, if they're not gone already.
Gotcha. Another question from Margaret. She wanted to know if you had any opinion on phase change materials for south walls.
Yeah, I was looking into those in 1978. I think they're out there, but I don't know anything about them. I'm sorry, and I'm a little sarcastic, because it's one of those high-tech solutions that's always been in the periphery but never made it to the mainstream. And since my focus is really on how do we make every single house a zero energy house, the things on the periphery are going to have to get a whole lot cheaper in order to become an essential part of that mainstream house.
Gotcha. We got a question from Dee, wanting to know, do you see electric co-ops advocating or not advocating for solar incentives? And she goes on to state that her codes are requiring gas wall heaters. And as I just asked her where she lives, so I'm hoping to hear back from her.
Mm-hmm. Yeah, that's interesting. I think there's a little bit of turbulence here as we begin to move forward. The publicly owned electric utilities have been slow to adopt some of these more aggressive energy requirements, and I think that's based to some degree on the way that they finance their electric generation, and they're able to provide their customers with very inexpensive electric power, but it's limited, and so they can't overextend their resources. And what I'm hoping is that the co-ops and the PUDs out there will begin to take a little bit bigger view of the world and say that they can serve their customers better by investing in renewable energy and then providing that at a reasonable cost to their customers. Part of that is not shifting the load over to the gas company or to the propane company, but accepting the load that through electricity, through their electric system, that they can actually provide an affordable way of supplying that energy. So I think that there's been some changes recently in many of the many of the co-ops and PUDs in the public sector are starting to shift their thinking a little bit, but it's been slow to take hold.
Okay, and just for context, Bruce, Dee says that she lives in Sisters, Oregon, but she also has an off-grid cabin on Mount Shasta in California.
Okay.
Central Oregon Co-op is who she's dealing with there. So
right down the road from me.
All right. Okay, so final question I've got here in the queue is from Sharon, and it's going to be about retrofits. So how can we easily swap out old oil tanks in 1950s ranches and capes for ductless mini splits in New England developments, but then create a community solar system for those same developments?
Wow, that's not a small question, is it?
Right. That's a lot of work involved there.
There's a fundamental shift of thinking, but I think it makes some sense to try something like that. If you have especially if you have a publicly owned utility, electric utility, especially, that is willing to kind of facilitate that. But before you go too far down the fuel switching path, it's important to make sure that each one of those capes each one of those houses is as efficient as possible. It's very tightly air sealed, well ventilated, lots of insulation. It's got great appliances. And then when you go to supply the space heating, you can use a much smaller system. Ductless mini splits are really great devices. They are not a replacement for a big, huge furnace, however. And so you get into more trouble with mini splits if you try to have many branches, and that it's also, they can't overcome the heat loss of a fairly old home. So I think that, as we've always said, conservation is first. You got to conserve as much as possible in those homes, and then try to replace the heating systems with something a lot more efficient, and maybe you can run those mini splits off of solar, kind of a community solar electric system too.
All right. Well, that is going to wrap it up for our questions for today. Thank you so much, Bruce, for sharing your time and your knowledge with us. We really do appreciate it. I also want to say thank you to our enormous audience that we had today. Thank you for attending. Thank you for your engagement, your questions. That's what makes this stuff even better than the presentations themselves, is that interaction with you all and getting to the issues that you care about. And I also want to thank NV Energy for their generous sponsorship of this webinar. We're going to see you back here in 2 weeks, and you're not going to want to miss our next webinar. We're going to be discussing the results of the 2021 IECC voting. If you haven't heard yet, the vote went decidedly in favor of energy efficiency. Now, we're going to be joined by not one, but many guests, including Bill Fay of the Energy Efficient Codes Coalition, Mayor Kevin Burns of Geneva, Illinois, and Jennifer Taylor from the Nevada State Energy Office. So won't you join me back here on Wednesday, February 19th at 2 p.m. Eastern Time. I hope you'll tell all your friends and tune in yourself. Until then, have a great Valentine's Day. Take care, everyone.